Hello everyone, welcome to this video. Today we are going to do a practice question on the topic of projectile motion. So here in front of me I have a practice question. So let's go through it first and see what it's trying to ask. So there's an archer. An archer shoots an arrow at a 75-meter distant target. The bullseye of the target is at the same height as the release height of the arrow. If d is equal to 75 meters and the velocity is equal to 37 meters per second, at what angle must the arrow be released to hit the bullseye if its initial speed is 37 meters per second? So before we go on to solve the question, it's always a good idea to highlight or to understand the most important facts of the question. So we know that the arrow is being shot at a 75-meter target. The bullseye, the target, which is right in dead center. So like this is the bullseye. It's the center of the target. This one, which is the bullseye of the target is at the same height. So the bullseye is at the same height as the release height of the arrow. And we know that the distance between the point at which the arrow was shot and where it landed is 75 meters. So we know that the distance between the 2 points is 75 meters, and the velocity with which it was released is 37 meters per second. So one thing I'd like to add here is that when we say that the velocity with which it was released, first of all, velocity means that it's not just speed. Velocity involves direction. So it's, let's say I throw a ball let's say north, in the north direction with a speed of 10 meters per second. So that means the velocity of the ball was 10 meters per second due north. So okay, so at what angle? So this is the main part of our question. This is the task at hand. At what angle must the arrow be released to hit the bullseye if its initial speed is 37 meters per second? So it's always a good idea to draw the schematics of the question first. This is point A. This is the point of release. Okay. So we know that this the point of release and the point where the arrow landed on the bullseye is at the same level. So we know that if we draw a straight line, both point A and point B would fall in that line, right? So we know that the arrow was launched at a velocity of 37 meters per second. We don't know the angle. So we need to figure out what the angle is. So here I've denoted the angle as alpha. Okay. So we know that this is a projectile motion question, right? So whenever projectile motion is involved, there's a very basic thing that we need to take into account. That is that we need to keep in mind that there's a gravitational force acting on the arrow at all times. So there's a downward acceleration of the arrow. Let's say the arrow is over here. Okay, so this is the arrow. There's a constant gravitational force being applied. So where there's force, that means that there is acceleration, right? About the formula, force equals mass into acceleration. So mass is a constant here. So that would mean that force and acceleration are directly proportional. So we know that there's a gravitational force acting on the arrow downwards at all times, and that means there's an acceleration, a constant acceleration that is acting on the arrow. So we know that gravitational force of the earth is around 9.8. So just because this is a question where I'm going to try to give you the concept of how it's solved, we're going to make an assumption that the gravitational force is 9.8 meters per second square. Very careful with the unit there. Okay, so we need to find alpha. Yeah, we need to find alpha. That's the question. I realize that I'm repeating quite a lot of details of the question, but that's important if you're new, if you're learning how to solve questions that involve projectile motion, because it's very important to get your understanding right. So we have an equation here. So this equation involves finding the angle or any of these variables. Let's get into the details of this. So sine 2 alpha equals GDH is horizontal displacement. So we know that the horizontal displacement is this part, that is 75 meters. We know gravitational force or the acceleration, the downwards acceleration, which in this question means the vertical acceleration. So as we know, this is vertical, this is horizontal, this is the vertical acceleration, this is the horizontal displacement, and this is the initial velocity. Okay, so let's go over the formula again. Sine 2 alpha equals GD over V squared. So I've labeled this for your convenience. Okay, so let's use this equation. We know that sine 2 alpha equals G, which is 9.8, as we made the assumption here, multiplied by DH. We know that DH, the horizontal displacement, is 75 meters. So 75 meters, and that's divided by the squared of the initial velocity. We know that the initial velocity is 37 meters per second. Okay, so after we so we have this expression, right? Let's simplify it. But before we do that, we know that if we want to obtain this value, if we want to know what 2 alpha is, right? So we take an inverse function of sine, and in that inverse function, this part goes in the inverse. So sine inverse, basically, sine inverse, this part, we lifted this part and put it right here. Sine inverse 9.8 into 75 over 37 squared, that equals 2 alpha, right? Okay, so when we applied the inverse function, we now have the value of 2 alpha, but we need alpha, right? Okay, so let's divide both of the sides by 2. That would mean that now we have this expression, 1 over 2 into sine inverse of 9.8 into 75 over 37 squared, that is equal to alpha. Simplify it further and then you get this answer. So we know that the arrow was released at 16 degrees, and that is what allowed it to reach the target at this distance with this initial velocity to land at a point which is at the same level as when it was released, at the same level of release of the arrow. There is one other thing that I really wanted to mention. So let's have a look at the question again. So we made this assumption in the beginning that the gravitational acceleration is 9.8 meters per second square. That means that if the velocity of this arrow, an upwards velocity, is being affected by that downward force, which is gravity, gravitational acceleration. So there's a downwards acceleration in an opposite direction. So it's opposing the direction, right? So that means that it is some sort of resistive force. Not resistive force, it is somewhat decreasing the vertical velocity vector. So what does that mean? That might confuse you, but let's clarify that as well. So when there's velocity at an angle, which in this case is 37 meters per second at an angle of 16 degrees, which we calculated. So there is a horizontal vector of this velocity and there is a vertical vector of this velocity. So both of these contribute to make 37 meters per second velocity at 16 degrees. So one way that this can be calculated, which is a topic for another video, but let's talk about it very briefly here. So this vector is cos 16 degrees multiplied by very sorry for the okay, so this vector is cos 16 degrees into 37 meters per second. That means that something that is traveling at this angle, it has an upward velocity of cos 16 degrees multiplied by 37, and it has a vertical velocity horizontal velocity of 37 sine 16 degrees. So this is 37 sine 16 degrees. Okay, so this is the case. There's something we need to be very mindful about here, is that this velocity, the vertical velocity and the horizontal velocity, which make this velocity, this is instantaneous. This is only at the point when the arrow is released. So that's the very reason we include initial velocity here, because the velocity is changing. And why is the velocity changing? Because there's acceleration. However, the acceleration is in the vertical plane. So this component, this velocity, will decrease, or it is being opposed by the gravitational acceleration. So as the arrow moves, you will notice that after a particular point, it starts moving downwards. Why does that happen? Because this velocity, the vertical velocity, is changing. However, the horizontal velocity in this question, in an ideal scenario, is constant. So we need to take this into account, because if this was not constant, let's say there was air resistance. So air resistance, if you throw a ball in this direction, air resistance will act in this direction, right? So that means that over time, when it covers a distance, its velocity, let's say if in the beginning when the person threw this ball, it was 25 meters per second, but let's say when it reached here, it was around 22 meters per second. Why? Because there was an opposing force, an acceleration, which was actually, in other words, it was a deceleration. So the acceleration was decreasing this velocity, and it decreased it to 22 meters per second. Why? Because it was in the opposite direction. And here in this question, we made the assumption, let's write it down, that there is no opposing force or drag or resistance in the horizontal plane. So there is no resistance, opposing force or acceleration in the horizontal plane. So this is the second assumption that we made for this question. So if there's no acceleration, that means that this speed is not being affected and it remains constant. It remains at a constant value of 37 sine 16 at this point, at this point, at this point, at any point. It remains the same. Might I remind you that we are still talking about the horizontal velocity, and we discussed in detail why the vertical velocity is changing because there's an opposing force. I hope that any confusions have been clarified and that you can now um, easily solve questions involving projectile motion, especially in the case where you need to determine what the angle is at which a projectile was launched. Thank you very much for watching this video. Share it with your friends, with your colleagues, and whomsoever you think this will help. Please like, share and subscribe this video if you liked it and if you found it helpful. And this is one of the very first videos of this channel, and I would really appreciate your support if you could subscribe to this channel, help me grow this channel so I can make more content and help you solve more questions and build your concepts. So see you in the next one. Thank you.